Okay, this is the practice test for chapter 6. I'm going to go kind of fast because this could come out to a pretty long video. So I figure you can pause it if you get stuck. But hopefully you've done the whole test because these are the same problems you're going to see. And this is just to check your work and learn something after you've tried it and maybe made some mistakes and you can correct it. Just watching the video without trying it first is really not going to help you too much. Okay? Here we go. To find the number of triangles, if it's side, 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 it's always going to be one triangle. But just to make sure that the longest side doesn't keep the two shorter sides from touching each other. Okay? So the sum of the two shorter sides has to be longer than the longest side. In this case, the longest side is 6. The two shorter sides is 2 and a 3. And 2 plus 3 is too short for the 6. I think of the longest side as like a chaperone. If the chaperone it keeps the two shorter ones from touching each other, then you cannot have a triangle. Okay? Hope that makes sense. Right. When given angles, check the sum equals 180. If you're talking about a triangle, they have to add up to 180 degrees. So in this case, when you're given one angle, make sure that's less than 180 because you're going to add two more angles to it. So this is impossible. And when you're given two angles, you have to add one more angle to it. So make sure it's less than 180. Okay, so this will not work. If you're giving all three angles, make sure they add up to 180. This adds up to 179, so that's not a triangle. Okay. If you give me an angle, 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 you can tell how many triangles there are. It's always going to be one as long as they add up to 180 degrees, but it does not define a unique triangle. You can't do anything with the sides. You don't know how big that triangle is. You just know the angles on that triangle. Now, here's our finicky ASS ones, and for obtuse it's either going to be one or none. For the acute one, there could possibly be two triangles. Okay, and we'll get to the next slide for that one. And for the other ones, make sure that these rules pass, right? If they add up to 180, then for sure there's only going to be one triangle. As long as they add up to 180, they're possible to add up to 180, then these are all fine. So now let's get to the hard ones, the ASS ones. Okay, for an ASS, if the opposite side is longer than the adjacent side, then there's one triangle. Okay, in this case, the 6 is opposite, right? Opposite, when you're drawing the triangle, the same letters are the opposites. So if this is angle A and this is side A, so this is the opposite side to this. So that means that this is the opposite. Opposite is larger than adjacent. Then there's one triangle. Doesn't matter if it's obtuse or acute. All right. If you have an obtuse ASS and this is not true, then the only other possibility is there's no triangle. If it's obtuse, it's either going to be one. So if it's not one, then it has to be none. For the acute, then there might be none or two. Then you have to check the height. The height, you can find that by taking the angle, the sine of the angle, times the adjacent side. Okay, the adjacent side times the sine of the angle will give you the height. That comes from SOHCAHTOA if you want to look at it. The height is a 90-degree angle with the base. So the height is going to be larger than the opposite, and there's no triangle. Okay, like this one. I see that this is an ASS. This is my opposite. This is my adjacent. Find the height. My height is using this little thing here. I get 30. So 30 is too long for this opposite side. It's going to keep the opposite side from touching down and making a triangle. So there's no triangle. So if there's no triangle, the other one is if the opposite is longer than the height. Okay, and we already know that it is shorter than the adjacent. okay, because we didn't do this one over here. So like this, if we find the height is 30 and the opposite is 40, so you have a 50, adjacent's 50, opposite is 40, and the height's 30, then there are two triangles. Okay. All right, so number one, give the number of triangles. So we have an ASS. Now we have an ASS, and now the opposite is shorter than the adjacent, so we have to check the height. Okay, checking the height. The height is adjacent times the sine of the angle, so that's 36 times the sine of 47 degrees, and get 26.3. 26.3 is smaller than the opposite, so then that means the height is smaller than the opposite. We have three triangles. Got a 36 for the adjacent, 27 for the opposite, and 26.3. So there's two triangles. Number two, with a 38, 147. Okay, so if you look at these two numbers, you go, hey, they already add up to 185. That's no good, so there's no triangle. Number three, using the law of sines, solve the triangle. So when I'm giving you three parts of a triangle, I need three other parts. I need side B, side A, and angle A. Okay, so first I draw myself the triangle, label my given information, right? And I draw it as accurately as I can, an obtuse 98-degree angle up here. So this looks like about 98 degrees, and 30 over here. And this is just in relation to those two. So first, I'm going to use the law of sines because I have a pair. So you have a pair. I have a C and a C. So there's my pair. And that means I can get this pair. So I can get side B. Since I'm solving for the side, I like to put the sides on top and the sine of the angles on the denominator. Rearranging this with a little algebra, putting the sine of B on this side, putting this in my calculator, I get 63.4. So that's side B. Now angle A is pretty easy to find actually, since we know that the sum of the angles on a triangle have to add up to 180. So I take 180 minus the 2 that I already have. I get angle A is 52 degrees. And in side A, using the law of sines again, we have this pair, right? I'm going to use the C pair again, and now the A pair. And the A pair is going to be like this, moving the denominator sine A to the other side, putting this in my calculator, and I get 50.4. Moving on to number 4. All right, it looks like an angle, opposite side again, so we have an angle side side. Quickly draw that out. I can see it's angle side side. And since this is shorter than this side here, the opposite is shorter than the adjacent, I have to check the height. It's either going to be 2 if I can swing it over. If I can't, then there's none. So checking the height, it's adjacent times the sine of the angle, which is 10 times the sine of 24. That will give me 4.1. And 4.1 is shorter than the opposite. I have two triangles. So I'm going to finish this off with the law of sines. Okay, side B is arcsine of B sine A over A. Putting my numbers in, I get 42.7. Put that in here. And then my first angle C will be 180 minus the two given angles. I get first angle C is 113.3. And then using the law of sines one more time, I get 13 and down here. Now when I flip this side 6, opposite side over here, the length of 6, flip it over here, I get this triangle. I still get a 24-degree angle in here, 10, and still 6. So I still have the same information up here, except now all the angles are going to be all messed up, and the side C is going to be messed up. Okay, to find this angle B, B2, we take angle B1 and subtract that from 180. So B2 is 137.3, and that's the angle down here, this obtuse angle. And then we can find this second C angle, this little tiny one up here. It's 180 minus the 2 that I have down here. This one and this one. So I have 180 minus the 24 and minus the 137.3. I get 18.7. That's this little angle up here. Now to find this third side C, and then using the law of sines one more time, I get 4.7. And I quickly check to see if the proportions make sense to me. This is 10, 6, 10, 6, and 4.7. That's reasonable, right? And we have an obtuse angle here, and we have a nice tiny angle up here. Okay, so double checking the visually that I can see that this does work out. Okay, number 5, law of sines. One more time, we have angle 65, side 30 and 22. So the opposite is longer than the adjacent, so we have one triangle going on. Okay, so we just solve this with the law of sines. Get 41.6, and then this third angle, angle C, it's just going to be 180 minus the other two, 73.4. And then the other side, using law of sines one more time, I get 31.7. And just doubling the proportions here, that looks pretty good. All right. The largest angle has to be opposite the largest side. Okay, and the smallest angle has to be across from the smallest side. All right. Number 6, finding the area of oblique triangles. Okay, we know how to find the area of a right triangle. It's 1/2 base times height. But we're going to have to find the height a different way. If we have side angle side, we're going to take the base times the adjacent angle times the sine of the angle times 1/2, because that's what the height is. Okay? If we're given side, 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 we have to use Heron's formula. All right. So this is Heron's formula, and S is the sum of all the sides divided by 2, or half of the sum of all the sides. So number 6, find the area. This is angle, side, so I use this formula here. Okay, and then 1/2, the base is 12, the adjacent side's 15, times the sine of 38, and that's approximately 55.4 square units for the area, as in square units. All right, use the law of cosines to solve the triangle. Okay, so now we have side, side, side. We're looking for an angle. So this is all out of order here. You have this formula. Okay, C on both ends, and then the A and B in the middle. So we have 10 squared, 18 squared minus 26 squared. Remember, when you're using law of cosines, finding the angle, you have to find the largest angle first. Okay, so the largest angle will be the angle opposite the 26. So you have to find that first. Otherwise, you might get an error in here. So that's 134.4 is this angle in here. And then I would finish this off here with the law of sines. So now I have a pair. So I can get angle A. It's 15.9. And then just using the sum of angles, I can get 29.7 down here. Number 8, again using the law of cosines. This time we're not side, 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 so we have to use a slightly rearranged formula for that one. So we're going to use this formula here. Still law of cosines. So that's really just the square, taking the square root of both sides so I can find C. And just putting all the numbers in here, I get 10 squared plus 8 squared minus 2 times 10 times 8 times the cosine of 55 degrees. Taking the square root, I get 8.5. Okay, and then using the law of sines, I can get angle B, and then using the sum of the angles in a triangle, I get 74.6 at the top for angle A. Number 9. All right. This is to see if you can conceptually break apart some angles when given something kind of complicated here. Find the length of the wire at the bottom connected up to the top of the flagpole. Okay, and the flagpole is the darker part here because this is a hill. This slanted line is the hill, and the flagpole's on the hill. That's 30 feet, the dark line here. And the slope of the hill is 8 degrees. Okay, and the angle of elevation is always from the horizontal. So the angle of elevation is 40 degrees from the horizontal. Okay, show your work. How long is this cable? Alright, if you had trouble with this, just look at it like this. Here's that big triangle, big right triangle. What do I know about that? Well, I know that this is 40. I know that this is 90. And we know this angle up here, which is going to be 50. Okay? Now there's another triangle up here. That's the one that's at the bottom of the flagpole and top of the flagpole to the ground up down here. That's this triangle. Well, what do we know about that? Well, we know that this top angle here has to be the same as the right triangle, this bigger right triangle. That's 50. So what is this angle down here? What is this angle here? Because we know that this is 40 and this is 8. So that better be 32. Subtracting the 40 from the 8 will give you the remainder of this part here. And we should get this angle too, because all three angles in a triangle have to add up to 180. So that's a 98. Do we have any other information? Yeah, we have the 30. It looks like I have a pair here. We have a triangle and we have a pair of, an angle on the side. So we're going to use the law of sines. We're going to find this. So we're going to use the law of sines. And have this pair going on and this pair going on. So I have x over the sine of 98 is equal to 30 over the sine of 32. Rearranging this a little bit, putting the sine of 98 on the other side, putting this in my calculator, and the length of that cable is 56.1 feet. Alright, number 10. Two planes leave LAX at the same time. One is flying at 475 miles per hour at a bearing of 345 degrees. That's starting from the north, going clockwise. And the other is flying at 525 miles per hour at a bearing of 78 degrees, so also from the north clockwise. And determine the distance between the two planes after they have flown for 2 hours. Well, 2 hours at 475 miles per hour is 950 miles. And 2 hours for 525 was 1,050 miles. So they're flying away, and you're trying to find how far apart those two planes are. Okay, then that looks like, we have a side, so we need an angle in here to find this. So in between here, I hope that you can see that you already have 78. You're just missing this little piece in here. That little piece in here should be 15 degrees because it's 245 and it needs 15 more to get back up here. So that's 15 degrees in here. So the angle in between them, the two airplanes, should be 93. So it's 15 plus a 78. Now we're ready to do this. Okay, we have a side angle side. We're going to use the law of cosines. So the distance I'm looking for, side C, is a squared plus b squared minus 2ab cosine of c, all under the square root. Plugging my numbers in, I get 1,452.4 miles. Number 11, find the component form for the vector v, with the initial point at 5, 6 and the terminal point at -1, 2. Okay, remember you're going to subtract the two horizontal pieces, subtract the two vertical pieces, and always the terminal minus initial. Okay, so terminal minus initial. So we're going to have -1 minus 5 and 2 minus 6. So I get -6 minus 4. So that's my horizontal and my vertical component for vector v. Number 12, if u is equal to 1, negative 5, and v is negative 1, 2, find 2v minus 3u. So 2 times v would be this, minus 3 times u. Okay, doing a little distributing here, I get 2 times negative 1 times 2, and 3 times 1, and negative 15. Do my subtraction, negative 2 minus 3, and 4 minus a negative 15, minus negative becomes a plus. Finishing that off, ooh, there's a negative there. So negative 5 minus, or negative 5 comma, negative 5 comma 19. All right. Find a vector, unit vector in the same direction of u is equal to 7 comma negative 2. Unit vector is the vector u, 7, negative 2, over the magnitude. So we have to find the magnitude. The magnitude is this, the square root of 7 squared plus negative 2 squared, which is rad 53. Then that means my u over rad 53. Just separate them into 2 portions, the horizontal and the vertical portion. This is a fine answer for this kind of work. Or if you want to make it real pretty, get rid of the square root in the denominator. Okay. Number 14, write the vector v in trig form. So I want it to look like this. Okay. So even gives you the notation here. So we have to find the magnitude and we have to find the angle. So finding the magnitude, that's this 2 squared plus negative 5 squared, is rad 29. The angle, my reference angle, is going to be absolute value of the tangent of negative 5 over 2, which is going to be 68.2 degrees. Make sure your calculator's in degrees. If you're going to write the degrees, if you're going to write it in radians, then make sure your calculator's in radians. And because this is positive and then negative, we're in quadrant 4. So in quadrant 4, the reference angle is going to be, have to subtract it from 360 to get my real angle. So that's 291.8. And then write it in trig form. I get rad 29, cis 291.8 degrees. And if you want to expand that out, you can write it either way. This is understandable, but this is the more common way of writing it, and especially the way it says here. All right. Find the absolute value of 5 minus 7i. So the absolute value is just basically like the magnitude, the distance from 0. So 5 squared plus a negative 7 squared gives me rad 47, or rad 74. Write in trig form. All right, so first we need to find r, and then find theta. R is rad 53, and theta is negative 7 over negative 2. Take the arctangent and get 74 degrees. And since we're in quadrant 3, negative, negative, then we have to add 180 to my reference angle. Adding that, we get 254 degrees. I just rounded that up to a whole number. Okay, in trig form, we have rad 53, cis 254 degrees, or you can write it like that. Number 17, the product. The product of two vectors is to multiply the absolute values and then add the angles. So we're going to multiply the 3 over 2 times 6 and add the pi over 3 plus pi over 4. And I get, this reduces by 2, so this is really 9. And getting a common denominator, multiplying both of these by 4, multiplying these by 3, I get 4 pi over 12 plus 3 pi over 12. Remember, this is 18 over 2, or 9, or reducing it, that's still 9. And adding this, I get 7 pi over 12. Okay. Find the quotient. The quotient is you're going to divide the absolute values and subtract the angles. So it's going to be 30 over 2 cis 120 over 75, or 120 minus 75, so I get 15 cis 45 degrees. De Moivre's theorem. De Moivre's theorem says when you're given a complex number to the exponent, that's going to equal to the absolute value to that exponent, cis the n, or the exponent, times the angle. So we're going to find r. R is rad 13, and the angle, or the reference angle, is arctangent of negative 2 over 3, which is 33.7. Then putting all this together, this is equal to rad 13 to the 5th power, cis 5 times 33.7. So you get this, and we usually want this in trig form to match what was given. So we're going to have 609 times cosine of 168 degrees, and 609 times the sine of 168 degrees. Last one, find the magnitude and the direction of the resultant force. So the resultant force is this one right here. Now the first one, I'm going to call this force U, so it'll be 12, the magnitude times cis of the angle. And then the other one's a little more tricky. You have to put this angle over here. So that should be 105, because it's 360 minus 255. So now the other one is 14 cis 105. So adding all the horizontal components, all the cosines together, I get 50 or 5.3i. Adding all the sines together, I get 12.6j. And then that means my resultant force is 5.3i plus 12.6j. Now we want the magnitude, so we square them, add them together, and take the square root, get 13.7. The angle, again, we take the arctangent, and since we're in quadrant 1, both of these numbers are positive, so we're in quadrant 1, so the reference angle is my angle. Arctangent of this is 67.2. Alright, that's it. Try to make this short, but that means that I talked kind of fast. Okay.